Hello, mathematicians. So as you know, I am Miss McGinnis. I am also one of the math teachers. So I'm going to be kind of stepping in a little bit here and there to help you with your math while we wait for Miss Kroom to get here. I know you guys are so excited to have her coming, and you've been in good hands with Miss Potter. So we are definitely going to make sure that you get the information that you need. So today what we're going to do is look at the parts of expression. So you should be getting a handout from Ms. Tilly so that we can go over this document together, and I will try to get in there to check on you if I can, but otherwise feel free to send us a message in Canvas to ask any questions if you've got questions. But we are in this together and we are going to make it work. So let's get started. So we're looking at parts of an expression. Let me see. I'm going to turn off my camera. I think. Maybe I'm not. All right, here we go. Alright, so parts of an expression. So we are talking about expressions. So I know last week you guys started looking at order of operations and integers and things like that. So hopefully you feel pretty comfortable with that now. So today we're going to look at what an expression is and kind of dissect an expression into all the different parts. Okay? So what you're looking at here with this thing here on the left side, this entire thing is called an expression. So an expression is composed of several different things, okay? So you have what we call terms, all right? So the terms are the different pieces of that expression. So we have terms. So if we're looking at our expression, so the term 2x squared, that's a term. 4x is a term, and -3 is a term. So those terms come together to create our expression. And now the terms actually have different parts as well. So you have what we call coefficients, okay? So we have coefficients. Those coefficients are the numbers outside that are in front of each of the things that you're being multiplied. So what we're multiplying are variables. Okay, so let's take a look at our variables. So we have these variables, which are, in this case, x. So x are our variables. So the variables are those letters that represent unknown values, right? And then of course you have your constant, which is there at the very end, typically when it's written in standard form, and we're going to talk about standard form in just a little bit, but your constant is a single number. So constant here is -3, okay? So you see all these different pieces come together to create our expression. Now, we also have different names for expressions based on the number of terms that it has. So for example, this expression that we were just looking at has 3 different terms. Okay, so we're going to be able to name that. And I'll bet if you look at these words, you could probably tell which one represents this expression where there's 3 different terms. Okay, so the first one that we're going to look at is a monomial. So I know this is a math class, it's not necessarily an English class, but there are some things in here that kind of let you know what you're looking at. And that mon stands for 1. Mon is the one of those terms that represent 1. So a monomial has 1 term. So when you're looking over here, some examples, 7, that is 1 term. That is a monomial. Negative 8x squared, that is one term. So remember, the term has the coefficient, it has the variable. So negative 8x squared is one term. There are several things going on here, but it's still just one term. So that's a monomial. Now when we look at the next one, we're looking at a binomial. So if you think about bi as in like bicycle, a bicycle is called a bicycle because it has two wheels. So a bicycle or a binomial is an expression with two terms. So here you're seeing 5. For this first expression, you have 5, and then you have negative 3x. That's two terms. Here you have negative 4x squared, and you have negative 7x. Again, that's two terms. So notice that our terms are separated with addition and subtraction. Okay, so terms are separated with addition and subtraction. All right, so now the third one that we're going to look at is trinomial. So if you think about tricycle, well, tricycle has 3 wheels. Tri is that prefix for 3. So trinomial is going to have 3 terms. Okay, so we have 3 terms here. Right? All right, and then finally we get down to polynomial. So polynomial, poly. Okay, so if we think about that, poly, prefix poly, that stands for many. Okay, generally we name it monomial, binomial, trinomial, and then once we get beyond trinomial, we call them all polynomials. So polynomials have many terms. So here you have a polynomial with, how many terms did this one have? Think about that for a second. Turn to your neighbor. Tell them this expression has how many? How many terms does this one have? 4. Good. So this one has 4 terms. So once we get past 3, we're just calling them all polynomials. Okay? All right, now looking at these definitions down here. So we have several definitions. We have standard form. Okay? So standard form is when the expression is written in descending order, starting with the highest exponent. Okay, so starting with the highest exponent is written in descending order based on the exponent. Okay. Once you get it in standard form, the coefficient at the beginning, that we call that the leading coefficient, but first it has to be in standard form. So it's the first number if in standard form. So again, the first number, when it's written in standard form, now that's important, it's got to be written in standard form, or the number in front of the variable with the highest exponent. Okay, so it's the first number, or if it's written in standard form. If it's not written in standard form, then your leading coefficient might not be in the beginning. It might not be at the front of it, but it's going to be with the variable with the highest exponent. Okay. The next term that we're looking at there is degree, so the highest exponent. So the degree is just the highest exponent. Okay. And then we have some terms for polynomial based on its degree. So if it's a 0 exponent, that's a constant. Okay, so when we think about here, negative 3, there was not a variable there, right? There's not a variable there, but we could actually say that this could actually be written as x to the 0 power. Okay, so x to the 0 power. Think about your properties of exponents. Anything raised to the 0 power is 1, right? So negative 3 times x to the 0 power. That's where we get that constant. Okay, so the constant is the number without a variable because we don't write x to the 0. You've probably heard about some understood ones and some understood stuff out there. So it's the one that does not have the variable. Now, if it's if the highest exponent is 1, we call that a linear. If the highest exponent is 2, we call it quadratic. If it's 3, we call it cubic, and if it's 4, we call it quartic. Some of this stuff right here is going to come back later in some later units. But let's first look at some examples, writing them in standard form and coming up with the leading coefficient, the degree, the constant, and then we're going to call it something, okay? So, let's take a look at example 1. So example 1, we have 3 minus 5x. So we want to write this in standard form. So standard form says we're going to write it in descending order based on the highest exponent. So we're coming back and looking at this. We're talking about exponent on the variables. So when we're looking at this 3 minus 5x. Alright, so we've got some understood situations about to happen here. Okay, so 3 minus 5x. I'm actually going to rewrite this a little bit. Let me grab a pen. Okay, so let me grab a pen here. So 3 minus 5x. So if I put a variable with 3, it's got to have a 0 exponent because it's not actually there, right? And then minus 5 times x, and we understand the exponent to be 1 on that one. So when we go to write this in standard form, the highest exponent, so between 0 and 1, our highest exponent is 1. So negative, that negative is with the 5, so it would be negative 5x because 1 is higher than 0. And then 3 is going to come behind that, and 3 is positive, so negative 5x plus 3. Now we can come up with our leading coefficient. So now that we've got this in standard form, our leading coefficient is going to be right here at the beginning with the negative 5. Okay. Our degree, again, our degree is the highest exponent. So we've talked about what these exponents are. These exponents are 0 and 1. The highest exponent is 1, so our degree in this case is going to be 1. Our constants, that's the number without a variable. So our number without a variable is 3. Okay. Now let's name this. Let's go back the other way. So now we're going to name this. Okay, so it has a degree of 1. So we know, so it's a degree of 1, so we know it's linear. So it's a linear. And it has 2 terms. So it's a linear binomial. So it's a linear binomial. Okay, turn to your neighbor and talk about that for a second. All right, let's look at example 2. All right, so example 2, writing this one in standard form. Example 2, there's not much there. There's just one term, right? There's one term, so it's already written in standard form, so 4x squared. Okay, so our leading coefficient, so the variable or the coefficient that's in front is 4. Our degree, so again, let's think about degree, is the highest exponent. So our exponent here is 2. So our degree is 2. Our constant, so we've got to be careful about this because 4 has a variable. Our constant should be without a variable. So our constant should be without a variable. So let's think about that for a second. Everything that I have, it's one thing, and it does not, and it has a variable. Okay, so I have one thing, and it has a variable. So how can I figure out what the constant is? if I were to add 0 to this, would it change anything about that? Or would it have the same value? So for example, if I had the number 7, that's just a side note right now. If I had 7, I want to add something to that so I can see something else. That's what I'm trying to do. I'm trying to see the constant. If I add 0, do I change the value of that? No, it stays 7, right? 7 plus 0 is 7. So I can actually add a 0 on here, and I can see my constant of 0. All right, so now let's talk about our name. So it has highest degree is 2, so it's a quadratic. So it's a quadratic, right? And it has one term. So one term, and we call that a monomial. So it's a quadratic monomial. Okay. Let's do one more together, and then you guys can finish these with your partners at your tables. All right, so one more together, number 3. So we have 3 terms. So we have 6, negative x squared, and 2x. Okay, so standard form. So I'm looking at standard form again. Standard form, descending order, starting with the highest exponent. So I'm looking at these. My highest exponent is 2. So negative x squared. So negative x squared. And then I'm going to have plus 2x because it's understood. Remember, it's understood 1. So plus 2x. And then my constant plus 6. Okay. The leading coefficient, now I'm going to see, so it's a negative. Now I'm not a negative. That doesn't make sense. It's a negative 1. Again, we got that understood stuff going on there. So the leading coefficient is a negative 1 because this negative, it's understood 1. All right, our degree, so our highest exponent here is 2. Our constant, so the number without the variable typically is going to happen at the very end, is going to be 6. All right, so let's name it. Our highest degree is 2. 2 is a quadratic. So again, this one is also a quadratic. And it has 1, 2, 3 terms. So 3 terms is a trinomial. So it's a quadratic trinomial. It's a quadratic trinomial. Okay, so I'm going to leave these 4 for you to work through. You can work through it with your partner in your table, and then what we will do is, if I can get in there today and look at it with you, I will. If not, I will check in with you tomorrow or another day. But make sure that you get this completed so that we can make sure that you understand the material. Thank you very much.